So next is the recursion. So give title in your book, recursive function or recursion. So in one function definition, if we call the same function, that type of function are called as a recursive function. So function call itself only. So in one function definition, if we call this same function, that type function are called as a recursive functions. So for example, what we are generally doing in one function to another function. Okay. So this is my main function. So this is 101, 102 line, 103 line, like this line number. These are the, in the 105 line, I am calling the ABC function. Here it will directly go my command to the ABC function. Inside the ABC function, there is the 205 line, 202 line, 203 line, suppose 201, 234, 205, 206. In the 205 again, I am calling the DEF function. Here 301, 302, 303, 304, 305, 30, like this way, there is the available. So when we call ABC function will inside that it will calling the DF function. DF function will complete that task. My command goes to here. Then after once DF complete ABC function will complete cast, then my command goes to here. So in the main function 105 to 106 we have to reach, we have to complete the ABC function. Inside the ABC function we are calling the DF function, so we will complete DF. Then after it comes the ABC, and then after it will come to the main function. So this is the general function calling we are doing. So I will draw inside the memory how it's. So this is my stack section. Suppose inside the memory of the stack section, all the local variable are stored in the local stack section. So this is my main function. Inside main function, last address will store, that is the 106 will store. 105 ABC function call next address will store in the my program counter. Then after here, so it will last address store. ABC function last address is 206 and it is calling the DF function. So this is my DF function. So once these are the thing, 1205 you go to DF function. So my program counter holding the address of the, sorry, this is my stack pointer is holding the address and program counter is holding the 301. Stack pointer is holding the last address 206. And here stack pointer have a stored temporary address is 106, here 206, like this way it is storing inside the memory. So like this way it's once this will come, then it's a push pop memory like this way. So these are the memory section. Once it's completed, so this is the terminated and come to here. So then it's completed, then come to here, then again it's 106 to start. Like this way my memory is working. So you can see here because of we are calling the 205, my memory is still available. Once df function will complete, then my abc function memory will terminate. Till the time it's available in the ram. So similar way, if this is the complete, then only ABC function memory will terminate and it will go to the main function. So like this way, it is storing the memory in the RAM area. So draw these things. We are generally doing what in the memory and what is the things.
Done.
Okay, then we will see example. So I will make p89.c. Here I will write the code. Then suppose I am calling the printf function hello dot slash n. Then I am calling the main function. So function calling itself only, that is called recursive function. And printf, hey, I will say bye. So here it will print hello, then it will call the main function again. So I will explain the memory diagram later. GCC p89.c. So how many times hello will print and how many times bye will print?
Hello, it will print hello only.
Yeah, infinite time hello will print.
Yeah.
Yes, exactly. Hello will print continuously till my stack will not get full. That means overflow. Once my stack will full, so it will generate segmentation fault. So I will terminate this program. So the no meaning of this program, like this, that type of program. So how it's in behave in the memory. So in the memory stack area, this is my program and stack. So in the main function, there is the three lines, 1, 2, 3. So I will write like this way, 1, 2, 3 lines. So this is my main function. Again, main function in the first line, it's complete. It's in the second line, it's calling the main function. So once it's called the main function, again new stack will created. This is for main one. So inside main one, again two lines, 1, 2, 3. One completed, two. Again, it is calling the main function. So new memory will created. Then main 3. So like this way n number of main will created here in the stack section. So we have seen in what happened in the normal function call, similar way here also happened in the, so in the normal we are calling the abc function, then abc functions memory created, then we are calling the df function memory. Once df completed, then it will came to the abc function. Once abc completed, then only it came to the main function. So like this way it's works. So similar way here, once this last main function will completed, then only it's, but here we are calling the main function again and again, so it's not coming back here. So because of that reason, it's continuously calling the main function and continuously hello will print. So one time stack will full, at that time our compiler will generate runtime error as a segmentation fault error. So we will get a segmentation fault error. So stack is continuously increasing and there is no coming back here. So one time it's full, that is compiler generate the segmentation fault. So write down this stack is keep on increasing, that is no coming back. So one time it's full, that time compiler will generate segmentation fault. So when we use recursive functions, so function calling function itself, you have to put at least one condition. So yes, and write down this here. When we use recursive function, you must have to put one condition. So here I will take one integer I is equal to 0, I plus plus. If my I less than 3, and I will call the main function. Here, if I will make my I as a auto variable, then again the problem is same. If I will make my I as like this way, so my again problem is that I is equal to 0, I plus plus, that means 1 less than 3 condition will true. Again call the main function, it will make the I as a 0 again. So again this is the continuous loop, but there is no meaning. Otherwise I will put as a static. So static, that means reinitialization is not possible. That means once it will initialize I is equal to 0, then again main function call, it will not do the reinitialization and it will coming back to that. And because of that reason, here my 3 times main function will call, and then last how many times by will call.
One time.
So I will run this code. 3 times by will call. How? So see this recursive concept carefully. You can see here, this is my main function is calling to ABC function. So main function is again calling to main function here. But here instead of this, it is calling to ABC function. Once ABC function will complete, then only it will come to the next part of the main function. So that's we have seen. So in the memory area, this is the main function completely available here, ABC function completely available here. Similar way, when you call again main function, your complete area of main function will be copied in the next section, not only the particular area. So this is my stack. This is main. So 1, 2, 3, 4, 5, 6 line is there. 1, 2, 3. This is 4. I can say this is 5 and this is 6 line. So this is the 1, 2, 3, 4, 5 and 6. 5 line main function will again call. Then again it will create 1, 2, 3, 4, 5, 6 line here in main 1. So here 1, 2, 3, 4. Again it's called the main function. So 1, 2, 3, 4, 5, 6. So here 3 time hello is already printed. 1, 2, 3, 4, 5. Okay. So 3 times 5 also completed. The main function is called 5 also completed. Here main function will not come and it will directly come to the printf by. So here it will print by. Once it will done, it will directly go to here. Who called main function? This one. Similar way here. We have already seen in this. You can see here first main function is calling to ABC function is calling to DF function. So here my memory DF function will complete, then only ABC function. So it will go to the ABC function, then it will go to the main function. Similar way here, main function, who called the main function? So main one. So it will go to here. Here also it have already completed the fifth line, not sixth line. So here both way, fifth line is completed, and again it remaining parts what is there, so that is here, it will start from here and pi will be print. Again it will call the main one function here, so it will go to here and complete the by. So because of that reason, 3 times by will print. Understood this?
Yes.
So whenever we call the function, that complete replica is replaced, not only that function and rest of the things. Main function call, that means complete replica of the main functions, it is stored in the stack section. Sorry, again I will explain you. 1 2 3 4 5 6. So this is the stack. Inside the stack, this is my main function, memory is created. So one, there is 6 lines, so 4 5 6, sixth line is replaced here. 1 2 3 4, and fifth line when we call again main function, so complete replica of memory is created here. 1 2 3 4 5 6, 1 2 3 4 5, and sixth line, this is my main one. So again one more replica, 1 2 3 4 5 6, 1 2 3 4 5 and 6. So then that is the main two. Here in the sixth line it will print the by. It's completed, it command goes to here. Here it will not started from the starting line. Why? That is the mistake we are doing generally. We are saying that it is coming back to here, so it is started from, why not started from started line and directly sixth line? So in this function you can see we are calling the df function. Df function once complete that task, so it will not direct start to ABC function from the starting line. It will, wherever it's called after that line, it will start it. Similar way in the recursive function, wherever it's called after that line, it will start it. So that line have by. So here by will print again, and this main one function is completed, then this command goes to main function, and here it will by will print. So like this way it print. So write down this.
Done.
Yes. And so recursive is acting as a loop. So you can see here 3 times hello is printing, 3 times by is printing. So this is like similar like the loop only. So because of that reason, in the recursive we are not generally using the, we are trying to avoid the loops, and we are using the recursive inside the recursive function. So we are trying to maximum, trying to write in the recursiveness is acting as a loop Because of this reason, maximum void loops in the recursive function. So here, when we call the function, at that time we have to decide proper function prototype that will be return type and argument also. So that we will see with one example also. So decide a proper function prototype. So for example, we have to write return type and arguments. This is most important parts. We will see with example how to use this. Maximum try to write a code in if and else part. So that is the if and else condition we have to write the part. Okay, so these are the basic rules we will follow. Then we will see one more example. So this part complete.
Just wait.
Okay.
Yes, done.
Mm, okay, then next program. So this is most important. Design a recursive function for finding the factorial of a given number. Design a recursive function for finding factorial of a given number. So I will write down the code first, then I will explain this. So here my return type is the integer and my factorial, I am calling that number is also a integer. So integer number, my return type is a factorial, and I enter the number. Scanf percentage d comma address of the number. So f is the factorial of number is equal to factorial of number we are passing here. And here in the main function we will print the factorial of a given number. Here my function is integer factorial of integer n. What we are doing in the for loop? or we can say in the while loop. So I will use while here, and while I will use my number. So my number is positive, then it will come here non-zero value. Then what we will do? We will do n is equal to n into n minus 1. So what is the factorial of 4? 4 into 3 into 2 into 1. So here 4 into 3 will store inside the n. So I will say here I have taken the f variable. And here I will do n minus minus. So my n is become 4 to 3. So here it will come 3 into n minus 1 is 2. It will store here n minus minus n become the 2. 2 into n minus 1 is the 1. Then n minus minus. So it's 1. 1 into 1 minus 1 is 0. So then 0 will store inside that is the not right case. So what we will put here? So we can do f is equal to n into n minus 1, and then after we are starting from here to n is equal to 1. Like this way we are doing in the looping concept. So these are the things we are doing. In we have to not use the loop here in the recursive function. First I will write down the code, then I will explain. So we will use here condition. If my number is positive, not 0, then after I will do here directly return my function, and I am calling to function itself only. What I am doing, n into factorial of factorial. This is my function I am calling n minus 1. In the else part, return 1. Okay. So how to put this n into factorial of n minus 1? So wherever we are calling the loop, that we will put the function. So how it will work? So this is my stack area. So this is my main function. Inside the main function, f is equal to factorial of 4. Suppose here it's called. My number is 4. So here it's called to the factorial function. So it will command goes to the factorial function. Inside the factorial function, my number is positive. Then it's came to the if part. Then I will put here if part. Inside the if, what I have written n into factorial of n minus 1. N minus 1, that is factorial of 3. So I am calling again here factorial function. So here it will came to the factorial, and factorial of 3, that means my number is positive. So here it will if condition again return n into factorial of 2. Then again it called to the factorial function, memory is created. If return n into factorial of 1. So you can see here my n value is what? Before calling the factorial function, my n value is 3. Before calling the factorial function, my n value is 2. Before calling the factorial function, n value is 1. And here it will come. So that is the if part is false, then it will come to the else part. So here it's a else return 1. Okay, then here my function return 1. So here my factorial where, so where it store here, if I am calling the factorial function, so it store in the f. Here I am calling the factorial function here, so it will come back to here only. So here my value is 1. So return 1, that means 1. So here my value n into 1. So n is previously 1. 1 into 1 is 1. Again it came to here and my value is 1. It's returning the 1 value only. So 1 into 2 is 2. Then after it is coming back to here and it is returning the value 2. So 2 into 3 is 6. And then after it will come back to here. So what is the factorial of 4 into 3 into 2 into 1? I did one mistake, anything? Yes, I did the mistake. Here my n value is 4. Before calling the factorial of 3, n value is 4, here 3, and here it's 2. So I will use eraser here. So here my return value is 1. Here number value previously is 2. 2 into 1 is 2. Then again it's calling the here, it's came to here and my value is here. Return value is 2. 2 into 3 is 6 value here. And here my return value is the number is 3. Sorry, it's 6. And 6 into 4. So 4 into 6, that is the 24, is the factorial of the 4. So like this way it's working. Wherever we are calling the function, then there only the my return type will come. So like this way, this will be the work. So write down these functions and diagram in your book. I will run this code. So my number is 4 and factorial of 4 is 24. So recursive functions are slower to compare to the loop, and it is taking much more memory in the stack memory. But sometimes it's beneficial also in the memory or concepts. So yeah, because of that reason, this is the implementation. So that's it for today. Tomorrow we will see much more in the recursive functions.